In the last video, we tried to understand what is a RAG architecture and why do we need it. Now, in that video, if you would have noticed, while indexing, what we are doing is we are first loading the PDF and then splitting it in chunks and then creating an embedding and storing that in vector store. Why do we need to split the text into smaller pieces, into smaller chunks before embedding? That is what we'll try to answer in this particular video. Now, what happens if we do not chunk our text? If we pass in the complete text, the issues would be as follows. Like if you pass in the whole document with every query that you're asking to the model, then it's going to cost you more because you're using up more tokens, right? So if you have like a large document and if you pass in that with every query, then that's definitely cost you a lot more money. The next disadvantage is token limits. If your text is longer than the token limit, then you're going to face errors. You're going to run out of token limits that the model offers. For example, in case of GPT-4o, the max token limit is 128K tokens. That comes around to be approximately 75,000 words. How you can convert this is every word is approximately every token is approximately zero point 0.7 words. So that's how you can convert this. So 128K tokens roughly approximates to 75K words. If your document has more words than this, then you're going to run out of errors. So the next issue would be performance. If you pass in the whole documents, the performance is going to be slow. It is going to be inefficient. That's where smaller chunks are faster and more efficient for the embedding model. The last but not the least is uh, if you pass in the whole document, then the context information gets diluted because LLM has to understand the whole document, which it does not have to, and it would not make a lot of sense. Shorter, well-defined chunks that you pass into the model uh, related to your question lead to more accurate leads to more accurate answers from the LLM. So that's where you'll see improved embedding quality, improved quality of your answers that you ask to the LLM. So I'll show that with an example. What we have here is a large document that is a ChatGPT research paper that I've loaded up in the doc reader object, right? If I print the raw text, you'll see this is a very large document. Now, what I did was I created embedding. I split the text first based on chunk size of 100. You'll see this is how the document got chunked, right? And next, what I did was I created a second chunk of that particular, a second text splitter of that particular text. But this time I gave the chunk size as 100,000, which basically means that there would be no chunks. This is a single text object inside this particular list, if you see, because the chunk size is too high. So the full text did not get chunked. And I stored it in text splitter underscore no chunking. Now we'll see the difference on what the AI is able to answer, right? So the text object which was properly chunked, I've stored it in doc search vector DB. The text no chunking, in which I gave a large split window and it did not get chunked, is stored in doc search no chunking, right? And then we'll try and answer then we'll try to get answers from the LLM. First, we get the answer from the chunk document. We asked what are the issues with ChatGPT, and it did answer me pretty well in a short and summarized format: accuracy, context understanding, bias, ambiguity, security, dependency on training data. Now, when I asked the same question, when I passed in the same query to docs no chunking, where we passed in the whole vector DB because we did not do any chunking. That led to a more ambiguous answer, a longer answer which has repetitive stuff in it, which might not make sense to me. So this shows that shorter chunks are better when you are dealing with longer documents. So that's it for this particular video. Thank you for watching. See you in the next one.